In this video, we're going to consider some of the main problems you need to be able to do in section 12.2. This video will not cover everything in the section, so it's important that you also take the time to read through the section on pages 611 through 615. Now, one of the things we are going to consider is how to do problems where it asks you about the shape of the cross sections parallel to various planes. So let's start right here. We first want our cross section parallel to the xy plane. If we are parallel to the xy plane, then z is going to be held constant. And if z is held constant, then we can take this. Remember, this can be just rewritten as z. Z is going to be our constant value. And everything parallel to the xy plane are graphs that are in the form x squared plus y squared equals c. And we should recognize right away, oh, that's a circle. C, the radius would be the square root of c. And so we have circles if we are parallel to the xy plane. Next, we look at the xz plane here. Y is held constant. And so if we hold y constant, our equation now looks like this. X squared plus c. You'll notice that I did not write c squared. If I square a constant, I just get another constant. Now what we should recognize right away is this is x is squared and z is not. And this should remind us that, oh, that's clearly a parabola. And then same thing over here. In the yz plane, x is held constant. And so we have z equals c plus y squared, which would also be a parabola. Now you can think for a moment, what does this look like? So if everything parallel to the xy plane is circles, so we've got circles going along, and these other ones are parabolas, you can imagine having parabolas this way, and I'll try and draw one this way, and the cross sections this way are circles, and this is what's known as a paraboloid. And this is not the best drawing of it, but if you go in your book on page 514, you'll see an excellent drawing of a paraboloid, and you'll see that if everything parallel to the xy plane, here's the xy plane, our cross sections are circles, and everything parallel to the other planes, you get these parabolas, and so you get kind of this bowl shape, but it's like an eternal bowl that opens up forever. All right, let's look at our next one. Very similar looking equation, only we have x squared minus y squared. So same idea here, xy plane, z is constant. So we let c equal x squared minus y squared. And if you remember back to your conic sections, if x is squared and y squared and minus sign in between, that would be a hyperbola. In the next one, we're going to hold y constant. When we hold y constant, we're going to get z equal to x squared minus c. And this is just like before, a parabola. The only difference with our last one is we had plus c, now we've got minus c. It's a constant. And then on this last one, we're going to hold x constant. And this one, we're going to have z equals c minus y squared. And this time we have parabolas again, but they open down. Parabola opens down, and this one is a parabola that opens up. Now this one's often harder for students to visualize, but what you actually have is a shape that's like a saddle. So this one is a saddle shape, or think of a Pringle. Pringle has that same sort of shape. And if you look on page 514 of your textbook again, you'll see a really good rendition of that. But I'll try my best here. So you've got this. No, I'm not going to try. You'll just have to look. This is a really hard one to draw 3D. But you'll see how the cross sections parallel to the xy gives you the hyperbolas, and you get parabolas that open down and parabolas that open up, depending on which plane you are parallel to. All right, the last one we're going to consider here is the equation of a plane, and I'm going to show you a really quick way to determine the x, y, and z intercepts. So let's just think to our coordinate axis. Here's x, here's y, and here's z. And if we're on the x intercept, we have an x coordinate, but both y and z are 0. And here, we have 0, y, 0. And over here, we have 0, 0, z. So that means that to find, let's start with our x-intercept, we're going to put in 0 for everything but x, and we get that x equals -1. And for our y-intercept, we put in zeros for everything but y, and we're going to get that y equals 1. And then for our z-intercept, we put in zeros for everything but z, and z equals 1. And then we can graph our plane using those intercepts. So it's one of the easiest ways to graph a plane. And so here's my x-axis. Now remember, if I'm -1, I'm going to be in this opposite direction. So there's that at -1. Y at 1, so I'm going to go over 1 unit here on my y-axis. And z is also at 1. And now you can see, so that's -1, 1, and 1. And now what we can do is draw in this triangle, which if you look right, you can see that the plane is the plane that cuts out that triangle. So it's one way to draw in a plane with a fair amount of ease. All right, so that should help you get going on the homework on section 12.2.